Good afternoon, distinguished colleagues and guests. It's February 17, 2022, 2 p.m. Moscow time. We're beginning the panel session for the defense of the thesis by Mikhail Anikushin. The thesis is submitted for the academic degree of Candidate of Sciences in Physics and Mathematics. The specialization is 112 differential equations and mathematical physics. The topic of the thesis is geometric theory of inertial manifolds for compact cocycles in banach spaces and its applications. Under the order issued by the Academic Secretary of St. Petersburg State University as of November 8, 2021, number 10772/1, I, Timur Makaev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Applied Cybernetics of St. Petersburg State University, was appointed the chairman of the board. The order also approved the members of the board, namely Elena Kudryshova, Doctor of Sciences in Physics and Mathematics, leading researcher of the Department of Applied Cybernetics of St. Petersburg State University. Rinat Yildashev, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Applied Cybernetics of the University. The following members of the board are working remotely today. Igor Burkin, Doctor of Sciences in Physics and Mathematics, Professor of the Tula State University. Igor, do you see and hear us? I do, and welcome you all. Yes, we welcome you as well. Sergei Zelik, Doctor of Sciences in Physics and Mathematics, Professor of the University of Surrey, Great Britain. Sergei, do you see and hear us? Yes, I do. Welcome you. And let me introduce our candidate for the degree. That's Mikhail Anikushin. He has two thesis supervisors: Nikolai Kuznetsov, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Department of Applied Cybernetics of St. Petersburg State University, is here with us. He's here with us. And Volker Reitman, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Applied Cybernetics of St. Petersburg State University. Unfortunately, he is absent today. I would like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and our board session is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions online to Mr. Anikushin, the questions regarding the thesis or scientific discussion, and thus they can participate in our discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and don't forget to state your name and position if you submit a question. The questions that have nothing to do to the scientific discussion or the thesis or the text of the thesis will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local regulatory acts, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. And the total number is not to be fewer than 4 people. Our Dissertation Board consists of 5 people. Everyone is with us today, including 2 members of the board who joined us remotely. And we have a multimedia connection with them, therefore we have the quorum. And I kindly ask the member of the Department of Dissertation Board Support, the curator of our defense, to fill out the attendance list. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's replies to questions, if any. Then, the candidate's presentation providing an overview and findings of the research. 15 minutes for that. Then questions to the candidate regarding the presentation, no more than 2 minutes per question. Then the candidate's replies to the questions, 5 minutes for all. Then the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the applicant for the degree. 10 minutes each. Then the chairman's report on the thesis. 10 minutes will be given for that as well, and the candidates' comments about the reports on the thesis and replies to the questions. 20 minutes will be given for all. Then open discussion, speeches by those present at the defense with a brief presentation of their positions or questions or suggestions to the candidate on the topic of the thesis. 10 minutes each. And at that, I kindly ask you to fill out the attendance list and to introduce yourself before I give you the floor. So, afterwards, the chairman will ask the questions submitted during the broadcast via our website. I would like to draw attention to the fact that written questions that will take more than 2 minutes to read out will not be voiced. The candidate's replies to the questions will follow then the presentation of the candidate's thesis supervisor. 3 minutes will be given to that. So we have 2 thesis supervisors. And then we may have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree, and the discussion of the results of the defense is not broadcast. Then we're going to have open balloting. We're going to count the votes and record the results in the protocol. Afterwards, we're going to make a decision on whether to confer the academic degree or not. And finally, we're going to give the floor to our applicant for the degree for the closing speech. And that's basically it. That's our agenda for today. Distinguished colleagues, any questions or objections? None. Okay. So let us proceed. And first of all, I would like to ask you to switch off the sound on your mobile phones. Thank you. So, let us start. So, the chairman's presentation. The thesis by Mikhail Anikushin for the academic degree of Candidate of Sciences in Physics and Mathematics, the specialization in 112 differential equations and mathematical physics, is titled Geometric Theory of Inertial Manifolds for Compact Cocycles in Banach Spaces and Its Applications. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued on October 19, 2021, number 9967/1. Mikhail Anikushin has prepared his thesis at St. Petersburg State University as a postgraduate student, and he has 2 thesis supervisors, Nikolai Kuznetsov and Volker Reitman. I've already introduced them. 7 published works describe the research findings, and there are 2 papers published in publications recommended by the Ministry of Education and Science of the Russian Federation, and 5 articles are published in journals indexed in Web of Science and Scopus. And all the documents provided by the candidate for the degree comply with the requirements and are found in the certification file, and the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the members of the board, distinguished members of the board, do you have any general questions to our candidate? Is there a need to consider the whole list of documents submitted by Mikhail? No questions. Okay then. Well, then we're going to listen to Mikhail's presentation. So, Mikhail, you have the floor. Thank you so much. So, the topic of the thesis is associated with finite dimensional reduction of infinite dynamic systems. And here we are talking about inertial manifolds. And such invariant varieties pull exponentially all the trajectories, and they have a global attractor. And this idea of finite dimensional pull was first announced by Hopf for hydrodynamics problems, and the first results were obtained by Manier for semi-linear parabolic equations. And the main interest arose after the work of Foyers, Sal, and Tema And for us, it's most interesting to consider the frequency approach to adjacent problems in works of Smith, Leonov, and Burkin. The main goal is to construct geometrical theory of inertial varieties in compact cocycles in banach spaces that are based on infinite quadratic functionalities like the type of Peterhof. And the second goal was to unite all these theories within the framework of the general theory of frequency approach of Smith, frequency theorem of Yakubovich and Lichtarnikov, and its development by Praskornikov. And that all leads to the development of fluctuations theory using frequency methods. That continues the works of Leonov, Burkin, Reitman, Kuznetsov, and other authors. The main object of our study is a cocycle in banach space E over the flow in metric space Q that is defined as the set of mapping set depending on two parameters, T and Q, continuous in combination. And for them we have this cocycle characteristic, and you can imagine that on every point Q you have a space copy E that's fiber over Q, and cocycle reflects this fiber over Q in fiber through time during the T time. And in order to form our formulate our main condition, let us consider the class of linear operators from banach space. And for them, we see the expansion of banach space into a direct sum of positive and negative subsets, subspaces, and here we should consider the sign of quadratic form operator PQ in this space. And they are evenly restricted, and they have a similar finite dimensionality J. And our main condition here is the compression condition regarding quadratic functionalities. And here we should consider formula 2. Here, in the right part of this inequation, we use weaker norm of space, and that's a Hilbert norm. And after that, we need to fill out the new element. And this condition is an integral analogy of the cone condition in differential form, and different variants were described by Leonov, Burkin, Smith, Zelig, and other authors. And we will also need Lipschitz condition that is executed in two types, overall general assessment in space E, and smoothing assessment using Hilbert norm from formula 3 that is added up after a certain period of time. And then we will need compactness condition that coincides with pre-compact subsets in metric space Q. And then we consider the class of orthogonal projectors. These are the projectors for negative space that have an expansion of the quadratic form into sum of values calculated on components of expansion for projector. And let us presume that the norms of such projectors are evenly restricted. Then we're going to consider full trajectories of cocycle, and here we see the convergence of integrals, and we are going to call them amenable trajectories, and we will define amenable fiber over Q as a set of vectors through which this amenable trajectory goes over Q. And so let us consider our main ideas. For the cocycle, if everything is true, for non-empty layers we have the following characteristics. First of all, the order related to the negative cone, and by Lipschitz homomorphically reflect the negative subspace with the help of VQ orthogonal projector. And also every spot from space E pulls to the demonstrates a pull. And considering additional conditions, we have a continuous dependence of amenable fibers from Q. and smoothness in case of semi-flows. So you can imagine the following geometrical image. On every spot of interesting layer, gray layer, we have a cone that divides this layer, and this transfers a green layer. And all these layers are reflected by projectors on negative and positive subspace accordingly. And along this layer, we have an exponential pool that was mentioned in the previous theorem. And now let us consider the following equation in Luria form. Let's consider this equation, number 8, to demonstrate algorithm to prove permanent operator presence. And here on the first step, we need to select some kind of quadratic formula that takes into account nonlinearity of f. And for us, the most important case is when, for nonlinearity, we have the Lipschitz condition, as in case with formula 9. And in this case, taking this in equation, squaring this in equation, we get the necessary quadratic function. On the second step, we differentiate the spectrum of operator n in vertical line, so that on this line we won't have the spectrum points, and here we have the g of eigenvalues. Then we need to check frequency inequality here, the performance of this frequency inequality from formula 10, and here we use Hermitian expansion if initial goal was in if initial problem was placed for meta spaces. And we can also use the frequency theorem in order to obtain operator P with much needed characteristics. And now let us consider a specific example that emerges in case of semilinear parabolic equations, when in the linear part we have conjugate operator with resolvent, and here we have congruence. And in this case, we can select such parameters of G and nu that lead us to the spectral gap condition. And this is demonstrated in equation 11. And from this, we can choose such a nu that minimizes the left part, and thus we get this spectral gap condition, this in equation from formula 12. And the previous option of Yakubovich-Tarnikov theorem that was proven in the 70s does not suit us well here with alpha and beta parameters, and for it we need specification that is described in the thesis. And now let us consider the following class of equations with delay. Here we use the standard definition for history segment, and we use Luria system. Nonlinearity is taken into account the Lipschitz condition, and we need to describe it as an evolution equation here. The standard choice of this space is the direct product of Renal2. And in this case, we define operator A using formula 15 and also operators B and C, and we get an abstract description of the system, like in the 16th formula. In the thesis, we study the correctness of this goal of this problem, its characteristics, and we go to suitable option for the frequency theorem that allows us to study such problems. And using this standard quadratic function, for such problems, frequency inequality should be written in transfer function terms that can be associated with a matrix here. Therefore, this condition can be represented like in formula 17. And we saw this condition in works of Smith that did not use the quadratic functionalities. And in the thesis, we consider the private case for equations with small delay, and we also see the applications to models of Goodwin and Soros shop. And here are the major provisions brought for the defense. There's the construction of theory of inertial varieties for complex cocycles and banach spaces, including the proofs for the construction of inertial varieties, then the proofs of new variants for frequency theorem for equations with delay, and the third is the construction of mapping and differentiation of semigroups for equations with delay in Hilbert space. The results were discussed at conferences that you see on the slide. Yesterday we had a report on the results of the work, and also I got a Rocklin grant and the grant of Russian Foundation for Basic Research for PhD students. And here are printed works on the topic. And also I have new preprints, and that's it. Thank you so much. Thank you. Now I have a question to the members of the board. Are there any general questions to our applicant for the degree on the content of the thesis, on the presentation? Yes, may I? Yes, sure. Mikhail, so the question is as follows. When we construct invariant variety, we use quadratic formula. If quadratic formula has two negative eigenvalues, then invariant variety is two-dimensional, and in two-dimensional variety we have certain system that can be studied qualitatively, and you don't need to know the exact structure of the system. And as it happened in works of Smith, if we made Bronker-Bendixson provisions, then we have a stable two-dimensional system. And if dimensionality of inertial variety is higher than 2, for example, 2 or 3 or 4-dimensional variety, and this is, can we describe system with inertial variety, and what problems will arise? How are we going to study it, and how are we going to make conclusions? Thank you so much for the question. Well, we can write it out in several cases. The general problem is associated with the same issue, how to describe equation on central variety, and this central variety is not local here, therefore it's quite hard to write down a specific system of equations, but in this case we can get certain expansion, for example with small delay equations. Chikane studied such equations, and Ryabov and Driver also studied them. And in this case you can write down the expansion of vector field on degrees of small delay, and this small delay will be a kind of parameter here. So overall, it's quite a hard task. Yes, are you satisfied with the answer? Yes, I am. So I was just interested to learn what should be done with multidimensional variants. Any other questions? None. Okay. External reviews. No external reviews, therefore. Now I'm going to give the floor to the members of the board with their reviews of the thesis. I would like to remind you that the applicant for the degree can answer all questions at once, or the questions of one member of the board, step by step. So I offer the second option. Now I'm going to give the floor to the members of the board, as all reviews were published on the St. Petersburg State University website. I offer you to give just the basic issues, questions, or criticisms. No objections about that? None. Okay, thank you. So first of all, I would like to give the floor to Elena Kudryshova. Can you please take away the presentation from the screen, because otherwise I can't see the colleagues. Yeah, thank you. So, Elena, please, you have the floor. Good afternoon once again. Do you hear me? Yes, thank you. Okay. Well then, the thesis is quite a good one. My review is quite positive, therefore I'll just give the basic points. So it should be mentioned that there is a high mathematical level of this work, the accuracy of a description, and good illustrations in the work. And as for the criticisms, I just saw certain misprints in formulas 1 to 43, 1 to 44. You missed sign ds on the signs of integral. And I also saw misprints on page 128 to 131, like to the periodical orbit, and so on. And there are English words in the Russian part of the thesis, like Adza on page 57, on page 136. Overall, the thesis by Mikhail Anikushin, titled Geometric Theory of Inertial Manifolds for Compact Cocycles and Banach Spaces and its Applications, meets the requirements of the order as of November 19th, 2021, number 111/81/1, on the procedure of granting academic degrees at Petersburg State University. And Mr. Anikushin deserves the academic degree of Candidate of Sciences in Physics and Mathematics and specialization 112 Differential Equations and Mathematical Physics. And Articles 9 and 11 of the above-mentioned order are not violated. Thank you so much. Helena, Mikhail, do you agree with the criticisms? Yes, I agree. Okay. Now, I would like to give the floor to our next member of the board, Rinat Yuldashev. So, Rinat, please, you have the floor. Yes. The work is dedicated to the study of nonlinear dynamic systems, such things as cocycles, central variety, inertial variety, and for these notions he expanded and summarized the frequency theorems. Overall, the thesis is pretty good, therefore I'll switch to the questions that I had and to the criticisms. So the criticisms. The definitions in some chapters are not chosen optimally, like CK, C comma in index and in sub-index on page 69. So it's easy to miss it all and to forget what they mean. And in theorem 121 on page 33, in condition you have 6 specially dedicated conditions that were applied far before that in the text of the thesis. And in order to understand what they mean together, you need to separately write them down, and this really hinders understanding. But these are insignificant criticisms that don't compromise the quality of work. And the question is as follows. In chapter 8.4, dedicated to the climatic model, you have certain ideas that detected multi-stability in the system can comply with irregularity of the described event on page 219 to 123, because the system is sensitive to externalities or noise. The question is as follows. Do you have any specific examples of such systems? But overall, my criticisms are more of a recommendation character, and I believe that the thesis meets all the requirements, and Mikhail Anikushin deserves the academic degree of Candidate of Sciences in Physics and Mathematics. Thank you, Rinat. Mikhail, you can answer. Yes, thank you very much. I agree with the first 2 criticisms. And as for the question of the experiment, yes, we conducted such experiments with the external powers, and we've taken a sine with amplitude as in the form of parameter. And in this case, with the growth of amplitude, we could observe how coupled quasi-periodic regimes like this here in the picture, they are stable for two trajectories, and to the right you see their dynamics. And to the left you see Poincare map for this period. And these two frequency regimes, with the growth of amplitude, they became automorphic with the emergence of sensitive dependency on the initial data. And then the regime became chaotic, and you see the growth of amplitude. So that's basically it. Okay, thank you so much. Renata, are you satisfied with the answers? And what's Y here? That's a different solution with close data with close element to X. So next review, Igor Burkin. Yes, I'm ready. Please, you have the floor. When I started reading the thesis, I understood that in the scientific school of Professor Reitman, that's not a first time when they talk about localization of invariant varieties. And therefore, I believe that was the thesis of Popov, headed by Professor Reitman. And this problem emerged when they resolved some problems associated with heating problems, and I was an opponent there. So it seems to me that something looked familiar here. So there are a lot of different results on inertial variety theory obtained in the second half of the 20th century. And these results required summarization for long. And the author had a goal to construct a unified geometric theory of inertial manifolds for compact cocycles in banach spaces. And the essence of this theory is to use quadratic functionals of Lyapunov, regarding which we have the compression of the system energy. And this compression guarantees the existence of finite-dimensional inertial variety, and it allows us to study the dynamic of the system in smaller size. And in the application, the quadratic functionalities are based on different variants of the frequency theorem. And this frequency theorem should vary depending on the class of studied systems. Therefore, the applicant had to prove certain variants of other frequency theorems, for example, for delay equations or parabolic equations. And as a result of all these studies, to my mind, for the first time, we have a finished geometric theory of invariant varieties for compact cocycles. And I would like to draw particular attention to the skill of establishing a proof of banach space. And the theoretical results are well illustrated, and their use in application of real systems is obvious, especially if we talk about two-dimensional inertial varieties, and we see the opportunity to analytically detect hidden fluctuations in finite dimensional systems, and that's, by the way, the field of Nikolai Vladimirovich. And therefore, I had the following question. That's not a criticism, but rather a recommendation. So when you detect hidden fluctuation in Saris-Kopf model, I believe it was excessive to consider the procedure of continuation along the parameter, because there the hidden fluctuations, a fluctuation is the only one, and maybe it could be detected in a simple manner, just starting from the remote, infinitely remote point. And the pool of this fluctuation, I believe, can be associated with this remote point. Do you know examples when hidden fluctuations in delay systems are numerous, and in this case there is a need to use continuation along the parameter to detect all these fluctuations. So that was the question, and in conclusion I'd like to say that the thesis by Mikhail Anikushin, titled Geometric Theory of Inertial Manifolds for Compact Cocycles in Banach Spaces and its applications, meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Mikhail Anikushin deserves the academic degree of Candidate of Sciences in Physics and Mathematics in specialization, differential equations and mathematical physics. Yuri Mikhailovich, thank you so much. Mikhail, you can answer. Yes, thank you so much for the remark. The answer is as follows. As for the examples, we didn't find specific examples, but we expect the opportunity to use them in equations of reaction diffusion where we have tearing patterns. In the simplest case, that's stability of that's heterogeneous states of equilibrium. And the intuition that emerged during the study of Soros-Schopf model can be used to study more complicated models. For example, like here. This model was offered by Boeing. It describes a ring mass of transmission lines without losses. And this system from you see here a delay in the derivative, and in the monograph of Go and Pu, a question was raised whether this system can generate stable non-simultaneous fluctuations. And using the intuition, this system in small parameters Q and D resembles the system of non-connected oscillators of Soros and Schopf. And using these small parameters in the area of stability and hidden fluctuations, we can find the following picture, where we see 4 non-synchronous hidden cycles. So they're hidden from the state of equilibrium. And then if we consider the parameters of delay, we can find a situation where one cycle is hidden and we have synchronous hidden cycle and 4 exciting cycles. And this model can generate synchronous and non-synchronous cycles. Thank you. Thank you. Igor, are you satisfied with the answer? Yes, very interesting. Really fascinating. Okay, thank you. Then, Professor Zelik, your review. Sir? Professor, you have the floor. To my mind, this work is really fascinating and important, and it is dedicated to such a classical topic as inertial variety and finite dimensional reduction. And the relevance of this topic is not questioned at all, because it is important both from the theoretical point of view, because it's important to understand finite or infinite dimensional systems that you're dealing with, and also from the point of view of application. Certainly, it's easier to calculate finite dimensional system. And this topic was quite popular in late 80s, first and foremost due to the dream to understand turbulence and to describe turbulence in a system of finite dimensional equations. Yet, unfortunately, this problem was much more complicated than we presumed before. And at a certain time, this topic was not that popular. And in this field, we do really need new ideas and new approaches to the problems that we have. And to my mind, this work of Mikhail introduces new ideas and new approaches. Mostly we are talking about some kind of unification of hyperbolic theory that is associated with the construction of hyperbolic normal variety, and on the other hand, that's quite a promising idea of bringing it together with frequency theorems. And we already see new examples of equations for which the existence of inertial variety was not previously known, but I'm sure that we'll see a lot of new examples, and I'm sure that this topic will be developed. And by the way, this work contributes greatly to this field. Yet I have several questions. I believe two of them are more important. One is associated with compactness of the cocycle. Usually in hyperbolic theory, this compactness and finite dimensionality does not play such an important role as even dichotomy of and even character and assessment of the cones. So there's a question, can we take away these conditions or maybe weaken them, compactness conditions, so that theory could be applied to a wider range of problems? And yet another question is associated with the dependency of cones from the point of phase space. And in this work, the cones or quadratic functionalities, which is basically the same, they were independent from the point, but there are numerous problems associated with spatial averaging where cones should depend on a point. So the question is as follows: how can we expand this theory to these problem classes? And in conclusion, I'd like to say that this work is performed at a very high technical level, and he elegantly proven the major results of the existence of normal hyperbolicity of inertial varieties. And to my mind, this work surely meets all the requirements. And I believe Mr. Anikushin deserves the academic degree of candidate of sciences. That's basically it. Sergei, thank you so much. Mikhail, you can answer. Yes, thank you so much for this remarks. As for the first remark on the weakening of compactness, so we can weaken it. We can weaken asymptotic compactness, and the Karatovsky measure should fade exponentially quickly, quicker than index nu. And as for the development of the theory, yes, I believe we should develop it. This dependence on point, new dependence on point. Well, that's already done, but I currently can't demonstrate this theory in full, but still the prospects are outlined already. That's it. Thank you so much. Yes, Sergei, are you satisfied with the answer? Yes, I am. Well then, my review was already published, as all other reviews, therefore I'm going to read the introduction and the result. So this thesis by Mikhail Anikushin is dedicated to the construction of theory of inertial varieties for compact cocycles and banach spaces. And within the framework of this topic, we see a variety of dynamic systems, mathematical models of physical, biological, climatic, and other types of processes. And other problems considered are associated with the description of asymptotic behavior of systems with the help of finite number of parameters. And then these problems emerged in second half of the previous century, and they are now currently actively studied, and they remain one of the key questions of applied theory of dynamic systems. Therefore, the topic of the thesis is quite relevant, and the results of the thesis are published in peer-reviewed journals, and the results were also presented at Russian and foreign conferences, and we saw a lot of preprints that were not previously published. And I would like to separately mention the volumes and the volume and the structure of the thesis, and also accurate and understandable representation of results that really creates a positive impression from the work that the author performed. And I have some minimal criticisms. Some of them were mentioned by Yelena, therefore I won't read them out, these negligible criticisms, because they don't influence the quality of work. But still I have some specifying questions that I wanted to ask. The first question regarding the problem of obtaining effective assessments of dimensionalities. That's problem 531 on page 146. If in general case the solution of the problem is hindered, then maybe it should be resolved within the framework of certain subclasses of equations with delay. Maybe you know such subclasses. That's the first question. And the second question, this development of Poincare-Bendixson theory allows to prove the existence of orbitally stable periodical orbits. Can we add up additional conditions and in order to get asymptotically stable periodic orbit? And the third question is associated with numerical modeling of Suarez-Tropsch model. In the thesis you use solver DD AI and 0.2 of Python. How can you explain the choice of this device, of this solver? And in conclusion, I would like to mention that the thesis by Mikhail Anikushin, titled Geometric Theory of Inertial Manifolds for Compact Cocycles and Banach Spaces and its Applications, meets the requirements of the order as of November 19th, 2021, on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Anikushin deserves the academic degree of Candidate of Sciences in Physics and Mathematics and specialization, differential equations, and mathematical physics. And Articles 9 and 11 of the above-mentioned order are not violated. So, Mikhail, please, you can answer. Yes, thank you so much for these questions. And as for efficient assessments of dimensionalities, well, we can obtain such assessments when we have small delay equations that are considered in the thesis, and we've proven universal varieties for them. For such a class of equations, we can see the following thing. We have general differential equations, and in some equations we wanted to take into account the influence of small delay on certain coordinate, and that's quite natural for electric chains. And for such equations, considering delay of as a small parameter, we expand the field using the orders of this delay, and in the zero element we have the initial vector field dimensionality assessment for usual differential equation when we use eigenvalues of the vector field will be preserved when we introduce this small delay if dissipation remains and Lipschitz constant does not change so much, and it becomes restricted. It's still restricted. As for the second question regarding the conditions for asymptotically stable orbits, yes, we can obtain such conditions, and the problem is associated with the study of isolation of periodic orbits and in works of Smith for ordinary differential equations. We saw the development of Poincare theorem for isolation for analytical vector fields. For vector fields on plane, it mentions that if a periodic orbit is not isolated from other periodic orbits, then we have a kind of adjacent ring that consists of periodic orbits. And then continuing this ring, we see the singular cycle, and isolation is based on different conditions. For example, the inability of different margins to exist in singular cycles, and such conditions are given in the terms of spectra of special points. For example, Dirac for singular cycles with saddles, all special points are saddles here, and he formulated for cycle case with one special point, and the Diller condition here looks like that. This number for which we have stable and non-stable set, it does not equal 0, and we can use this approach proposed by the thesis, and for Sorosov, Goodwin fits here Nagomo. And such systems have a finite number of isolated periodic orbits for parameters that exclude degeneration. And as for the choice of language, well, I've chosen it because it's quite flexible and easy to adapt. And Didient was chosen as just the first package that I saw, and it does not allow me to model sort of Shop model using periodical noise when you need to integrate the system on a long period of time in order to secure more detailed study of mapping. And therefore I've found package JITC, and it accelerated work several times. That's it. Thank you. Thank you so much. I'm fully satisfied with the answers, and I see huge potential here. Well then. So we're finished with reviews. And distinguished colleagues, a question to you. Is everyone satisfied with the answers? Yes, okay, great. Then, does anyone want to comment anything? Anyone? No one. Okay. Now let's take the questions that were submitted during our broadcast online. Do we have any such questions? None. Okay, no questions were submitted during the broadcast. Therefore, we shift to the speeches of the thesis supervisors. And I give the floor to Professor Kuznetsov and I ask him to read the review of Mr. Reitman. Yes, thank you so much. Unfortunately, Volker Reitman is absent today because of the pandemic, but yesterday I discussed this topic with him, and we share one opinion about this work, and I'm going to read it out, and then I'll read out the formal part of his assessment of the thesis. What do I want to say? We're talking about awarding an academic qualification to the applicant, and I believe that this work is performed at a very high academic level, and Mikhail demonstrated his qualification here. It is supported by the publications, by a range of publications that were printed in leading journals, including those in the first quartile. And this is also supported by direct grants from our mathematical community and personal grants from academic funds, science funds. I don't want to say that he performed huge work on binding very complicated aspects, on bringing them together, like theoretical studies, and also he ensured practical implementation, so the topic is quite broad as well, the connection of those studies that were of interest to Sergei Vitalyevich, like Babin, Vishek, Ulyanovskaya works associated with global attractors, and also those approaches that were developed by Professor Smith and Leonov, and certainly Igor Burkin, associated with the application of some frequency methods, and also Mikhail brought everything together and localized hidden attractors, so that all was demonstrated here in different fields, and the author demonstrated his high academic skill. And I won't read out the review my review and the description of the contribution of Mikhail. I've mentioned it myself. And overall, thesis is written at a very high, with a very high quality. All the results were obtained independently, and therefore I believe that Mikhail deserves the degree of candidate of sciences in physics and mathematics. And as for Professor Reitman review, he also mentioned the contribution of the author into the fields that I've mentioned and the high mathematical level. And in conclusion, Volker writes that high mathematical level of the work is also proven by by scientific activity of the author and by a number of publications in international journals. And he believes that Mr. Anikushin deserves the academic degree of candidate of sciences as well. Thank you so much. Distinguished colleagues, does anyone want to say anything? No one? Okay. Here we stop our discussion. Here we stop taking questions. And before we draw conclusions and before we finally vote, I would like to ask the members of the board and the applicant for the degree if there are any remarks or questions on the procedure of holding this event, maybe some questions associated with remote access. No questions? None? Okay. No questions? No questions to the procedure? Mikhail? No questions. Okay, then let's shift to the next item in our agenda, that's the vote. And I have a question to the members of the board. Dear colleagues, before we start the vote, we have an opportunity to have a 5-minute closed discussion that will not be broadcast. How do you think, do we need such a closed discussion, considering that overall the result is quite clear? No, no need for that. No. Okay, thank you. If there's no need for discussion, let us continue the session and let us shift to the vote. And I would like to mention that I would ask you to voice your opinion personally. So, it's 3 minutes to 3 p.m. and I raise a question on the award of the academic degree of candidate of sciences in physics and mathematics and specialization differential equations and mathematical physics to Mikhail Anikushin. And I would like to emphasize that by voting for the award of the academic degree, each member of the board agrees that Article 11 of the order is not violated by the candidate. And I would like to quote it. So Article 11. And thesis, the applicant for the academic degree is obliged to cite the author and or the source of materials or individual results borrowed using the results obtained by the applicant personally or in co-authorship. The applicant for the degree is obliged to know the circumstance in the thesis. And let me remind you that the decision of the dissertation board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people, voted in favor, in conformity with Section 17 on the order on the procedure of granting academic degrees at St. Petersburg State University. So, Professor Kudryashova, what's your opinion? I support this work and vote for the award of the academic degree to Mr. Anikushin. Thank you so much. Professor Yulashev. As I've written in my review, I also vote for the award of the academic degree to Mr. Anikushin. Thank you. Professor Burkin. Yes, I also vote for the award of the academic degree to Mikhail Anikushin and specialization, differential equations and mathematical physics. Okay, thank you. Professor Zelik, what's your opinion? I also support this work. Thank you. And finally, Timur Makayev, head of the board, also vote for the award of the academic degree to Mikhail Anikushin. So as for the results of our vote, distinguished colleagues and guests, I would like to announce that out of the 5 members of the board who participated in the voting procedure, 5 voted for the award of the academic degree, no one voted against it, and no one abstained from the vote. Thus, we award the academic degree of candidate of sciences in physics and mathematics, and specialization 1-2 differential equations and mathematical physics to Mikhail Anikushin. That's it. And now I would like to give the floor for the finalizing remarks to Mikhail. First of all, I would like to express my gratitude to everyone gathered here, to all the members of the board, to my thesis supervisors for their support, and to my parents. That's it. Thank you. Thank you very much for being brief. And we congratulate Mikhail Anikushin. And I would like to thank everyone once again, all the colleagues, all the members of the board, and also our colleagues who joined us online for taking their time and for helping us. And I therefore close our session. Yes, I thank everyone for participation, and I kindly ask to turn off the broadcast.